Record. Okay. Okay, guys. Um, so let me take you through the course website. This, um, give me a sec, guys. Share screen. This is the course website. I hope you can all see it. Um, and so as you can see, this website contains all the things that you need to know about this course. Uh, so for example, the first thing on the course website is the syllabus. So if you click on the syllabus, it gives you the timetable. The first 4 pages of this link gives you the timetable. So, for example, for this week, for this week, you have a review session 10 to 11, which is the one right now, and there are 5 tutorials. You need to attend only one of them, and the tutorial sheet is contained in this link, right? And for next week, the review session will be on 15th Feb, 10 to 11. There will be eight. There will be 8 tutorials, and you need to attend only one of these 8 tutorials, right? And the tutorial sheet is contained in this link, and so on. All right. So it gives you the full timetable for the entire semester, right? Okay, guys, and then. Um, Okay, let me zoom it in. These are my contact details, which I already sent to you by email. I hope you guys read my emails. So this is like my phone number, office phone. I also send my home phone number, the my Zoom link, my Skype ID, everything, right? You want to know. So, and plus, I'm also happy to see you in person 24/7 if you live in Manchester. And this is the link for the course website. This is a prerequisite for probability 1 is a prerequisite for this course. So I hope you guys enjoyed this course in semester 1. This is like overview of the course, intended learning outcomes, course contents, textbooks. I will show you the free electronic copies of these 4 textbooks are on the course website. I will show them to you in a sec, in a few minutes. Um, there are 3 kinds of assessment for this course. The first assessment are quizzes. There will be quizzes every week starting on 18th of Feb. Starting on the 18th of Feb, there will be quizzes every week. And the first quiz uh, the first quiz is contained in this link. So let me open this link, right? Okay, this is the quiz number 1. So there is a problem here, and there are four possible answers, and only one of the 4 possible answers is the correct one, and you need to choose whichever is the correct one, and log into Blackboard and then enter your choice. You should do that before you should do that before the deadline, which is 10 a.m. on the 5th of Feb, right? And soon after the deadline, you will get an email from me telling you what mark you got and what the correct answer is and how I got the correct answer. So the marking scheme is like 1 mark if you got the correct answer, and 0 mark if you did not get the correct answer, right? So there will be 10 quizzes. Like there will be 10 quizzes, 1 every week. The first one is on the 18th of Feb, and the last one is it will be on the 13th of May, right? And there will also be an R coursework, which is contained in this link, which is worth 10%. Each quiz is worth 1%, right? The R coursework is this one. All right, it is kind of a data analysis homework. which is worth 10%. R, as I said, R is a free statistical software. We will start learning about it from this week. The tutorials this week are all about R. So by the time you get to the deadline for this coursework, which is the 22nd of April, you should know enough about R to do the course, right? All right, and next, so that's the second coursework, and then there will be a final exam, which will be on in May or June of this year, and the stuff you need to know for the final exam, I mean the formulas that you need to know for the final exam are contained in these 2 pages, right? So you need to memorize these formulas before you go to the final exam. The final exam will be online, just like semester 1 exams. They will be online, okay? So you don't need to worry. I mean, it'll go smoothly. I mean, all right. So going back to this course website. So this is the course syllabus. Then, all right, there's this link here, which is, this link gives you the typed notes for this course. This contains all the notes, typed notes for the entire course, right? Right, and then, all right, then there is preliminary material which you should have looked through, and then there's week 1 material. Week 1 material it contains the videos for this week. I hope you guys had a time to look through this, right? These videos. There are 2 types of videos. There's the YouTube video, which if you have access to YouTube, you can listen to this video. And if you don't have access to YouTube, then you can use this UOM version, right? Like, for example, in China, you don't have access to YouTube, so you can watch the UOM version, right? And this is the tutorial sheet for this week, right? This is the tutorial sheet for this week. And there are 2 data sets we will need. And there will be videos of the tutorial sessions posted after the tutorials. And there will also be like a video on giving the full solutions to the tutorials after every week. So all the sessions, I must say that all the sessions, whether the review sessions or tutorial sessions, will be recorded. So you can visit the course website, which is this one, right? You can visit the course website to see like recorded versions of every session. So it's the tutorial sessions as well as the review sessions. You can see the recorded versions here, okay? So that's for week 1. This is for week 2, week 3, and so on until week 12. The week 12 is the last week of the semester, right? And then you have, right, these are the quizzes for 2018-19 academic year. This is 2019-2020 academic year. These are our courseworks and solutions for the past 6 or 7 years. So you can see what our coursework was like in the previous 6 or 7 years. These are in-class tests. There will be no in-class test this year, so you can forget about this section here. Okay, and these are final exams for the previous 6 or 7 years. So you can see the final exams and the solutions for the previous years. All right. Okay, guys, thank you. And finally, these are books. These are books. These are 4 of the books for the recommended textbooks for this course. So if you click on the link, like for example, if you click on this link, it shows the book. It takes ages to download, so don't worry. So I mean, these free electronic copies of the books are posted here, right? So you can see them, right? All right. So any questions you guys have you want to ask me before I start? Yeah. Every session you have to, every week you have to attend 2 sessions. Yes, there's a review session and also the tutorial session. The tutorial is should have been allocated to you in the timetable, right? So you should attend one, like for this week. For this week, you should attend the tutorial that you've been allocated to. So you should go back to the top of the course. You should go to this, right? You should have been allocated to one of these five tutorial sessions this week. And if for some reason if you cannot attend one of these 5 sessions, you can switch session. Like first, if you have an emergency, and you can't attend one of the session that you've been allocated to, then you can attend one of the other sessions. All right, is that clear, guys? I hope it is clear to all of you. Yeah, this week we use lab sessions to how to learn ARM. Yeah. All right, good, guys. Right now, I think you better attend the live sessions and plus see the recorded versions. I think it's not a good idea just to watch the recorded sessions only. Right? I think it'd be good to attend the live sessions plus watch the recorded versions. Okay. Okay, guys. All right. Now let me go through quickly the Zoom number is the same, guys. The Zoom number for the lab sessions is the same as the Zoom number. It's the same as the Zoom number for the review session, right? Okay. Okay, guys. All right. All right. Now let me switch the camera to. Let me switch the camera. Just a minute, guys. I'm trying to switch the camera to. Oh, just a minute. Okay. All right. Let me go back. Let me now switch the camera so that you can see the. Okay. Hopefully you can see it better now. So this stuff I asked you to ask you guys to watch. Um, I hope you watch the videos I asked you guys. So the first video I asked you guys to watch is about what is statistics. So this is the stuff that was written in the video. I'm just going through this quickly because you already watched the videos, right? So there's no need to explain. There's no need for me to explain things over again. Okay. Uh, all right. So this is the video on trends, popular trends in statistics. These are the four elements of statistics: population, sample, parameter, and estimate. And I gave you two examples on these four elements of statistics, right? This is example one, this is example two. The next thing I talked about was sampling, right? There is two different sampling methods. One is simple random samplings, the other one is called simple random sampling with replacement. The other one is called simple random sampling without replacement, right? Okay, so I mean there are other sampling methods in statistics, but these are the ones I will talk about in this course, right? And these are examples on SRS with replacement and SRS without replacement, right? Okay, and then there are variables. There are basically two types of variable: qualitative variables and quantitative variables. And quantitative variables can take two different forms: discrete or continuous, right? And in this course, mostly we will talk about quantitative variables. And if X is a discrete variable, then its probability structure is defined by something known as the probability mass function, right, which is defined by this. And if X is a continuous random variable, then its probability structure is defined by something known as the probability density function, or PDF, which is defined by this. And then there is this cumulative distribution function, which is defined by this. That's for both discrete and continuous random variables, right? And now, if X is a random variable, this denotes the population mean and is defined by these two, depending on whether the variable is discrete or continuous. And the variance is defined by this, right? And again, it's defined by one of these two formulas, depending on whether it's a discrete or continuous variable. And this is the definition for the population standard deviation: is simply the positive square root of the variance, right? And this gives you the nth population mean, and is defined by one of these two, depending on the variable is discrete or continuous, right? Then I did two examples. This example one is on Bernoulli distribution, right? So I derived the mean, the variance, standard deviation, and the nth population mean, right? And this is the second example I did, where X follows the uniform distribution. And again, I derived the mean, variance, standard deviation, and the nth population mean, right? And then, hello guys, be patient with me. Am I going too fast or what? These are stuff I asked you to watch beforehand, so I'm not gonna go through it in detail. All right, so I hope you're okay with that. Okay, thank you guys. Right, this is a video on the video on independent events or independent random variables. You know from probability one that events are independent if this is the case for two events, this is the case for n events. Now, variables are independent if this is the case for two variables and if this is the case for n random variables, right? So that's the definition. And this is a definition of a random sample. Random sample is basically a sequence of independent random variables that follows the same distribution, right? So that's the important thing you need to know. This is a first example on a random sample that I did in the video, and this is the second example on random sample I did in the video, right? Okay, and then I talked about sample mean and sample variance. The sample mean is defined by this, right? I should say here, I should have said here, suppose X is a random, X1 to Xn is a random sample with the expectation of x equal to mu and the variance of x equal to sigma squared. In other words, I'm assuming that each of these data points has population mean equal to mu and population variance equal to sigma squared, right? So then this is the definition of the sample mean. And there are two definitions for sample variance. Either this one is known as a biased version. This one is not, the first one is known as the biased version, and the second one is known as the unbiased version. Basically, what they mean is I mean, I will explain later in the course what a biased and unbiased means. Usually, the unbiased version is the better one. That the biased version is not good, right? So people normally, when I talk about sample variance, I will use this version and not this one, right? Okay. Now this is the here in this is a proof showing that the expected value of the sample mean is equal to the population mean. Right? So you should, once again, I'm not going to go through the proof, but if you had difficulties understanding the proof, please contact me 24/7 by whatever means necessary, right? So this is the proof of the fact that the expected value of the sample mean is equal to the population mean, right? Okay, and this is the proof. This one here is the proof that the variance of the sample mean is equal to the population variance divided by n, right? Sigma squared by n. All right, and this is example 1 on sample mean and sample variance. Yes, Michael. There is something known as, I mean, x bar here is the sample mean, and what I'm taking here is the variance of x sample mean, and it's equal to sigma squared by n, where sigma squared is the population variance, right? This is a proof of it. Okay, this is example 1 I did on sample mean and sample variance. This is example 2 I did. So these are stuff I ask you guys to watch. These are stuff now what I'm going to do in the remaining time, what I'm going to do, guys, is the following. I'm going to do some examples on the stuff. So I'm going to start with the first example. So I mean, my review sessions will go like this. I'm going to do, I mean, the purpose my review session is to go through the stuff as quickly as possible on the thing that I recorded already, and then do some examples, right? That's how I conduct my review sessions. All right, so okay, guys, so you don't need to submit answers to the tutorial sheet. I mean, the sample, you shouldn't confuse. I mean, sample mean it's a mean of a sample. It has nothing to do with the population mean. So when you take the expectation of a sample mean, you are taking you're computing the population mean of the sample mean, which turns out to be mu, right? So you shouldn't confuse sample mean with the population mean, right? Anyway, let's do some examples. All right, suppose maybe these examples will clear up things for you. right? So the example here is, guys, is you have a sample, x1 to xn is a sample from a distribution with the probability mass function given by this, right? And we want to find the expected value and the variance of the sample mean, right? So the first thing we must do is to find the population mean and the population variance. Remember, mu is this, right? The expectation of x is gonna be a times 1, which is a, okay? And sigma squared is the variance of x, which is gonna be the expectation of x squared minus the square of the expectations. All right, so this is gonna be a squared times 1 minus a squared, which is 0. So the can you follow me, guys? So the mean, the population mean is equal to a, and the population variance is equal to 0, right? So from what I just showed you, the expectation of x bar will be a, and the variance of x bar will be sigma squared by n, which is sigma squared is 0 divided by n, which is n, which is also 0. Right? You see what I just showed you a few minutes ago. Let me show them back. Let me show them again. See, this is the slide where I proved that the sample mean, the expected value of the sample mean, is equal to mu, which is the population mean of this, right? Okay, and the variance, or the population variance of the sample mean, is sigma squared by n, where sigma squared is the population variance of the excess, n is the sample size. All right, so what I have used here, guys, in this example here, I worked out the mu and the sigma. Mu is the population mean of the excess, sigma squared is the population mean of the excess, and then use the formulas that I just proved to find the expectation of x bar and the variance of x bar, right? All right, so this is one example. Let me do one more example, guys. So example 2, right? Yes, you are right. You are right, sir. So suppose all right, guys. So this is the second example where you have a random sample. You have a random sample from a population with a cumulative distribution function equal to x to the power a, x between 0 and 1, and we want to find the expectation of x bar and the variance of x bar. So the first thing we must do is to find the mean, the population mean and the population variance for the x's, right? So the PDF, I mean, what we are given is the CDF. So the PDF is the derivative of the CDF. Yeah, you know that from probability 1, right? So this is a times x power a minus 1, right? So the population mean mu is equal to is equal to 8 times is 8 times x times the density. Yeah, all right, x times the density, which is gonna be 8 times. Yeah, the population mean is the mean of the every x value in the sample. Yeah, there's only one population mean, guys, right? Which we denote here by mu, right? You take the limits from 0 to 1, and if you take the limit, you will get the mean to be a divided by a plus 1. Excuse me, right? So this is the mean, right? Now to find the variance, uh, variance of x, which is denoted by sigma squared, um, uh, I'm sure you guys know this formula here. This is the formula for the variance of variance, right? And this is, excuse me, 0 to 1 x squared a times x to the power a minus 1 dx minus a divided by a plus 1 squared. Please listen to me, guys. Don't just switch off the um, don't leave the Zoom, please. I mean, these are stuff important for you. All right, so this is what you get. Now if you do this integral and take the limits, you will get a divided by a plus 2 minus a divided by a plus 1 squared. All right, so this is the variance and this is the mean. So therefore, the expected value of x bar, x bar is the sample mean, is equal to a divided by a plus 1. Yeah, and the variance of x bar, the variance of x bar is, remember, is sigma squared divided by n. So it is simply 1 over n is 1 over n times, all right? Okay, so this completes example 2. Any questions on this example, guys, before I go to the next one? Is it, I mean, you shouldn't confuse the sample mean with the you shouldn't confuse sample mean with the population mean. They are different things. They're two different things, right? So here I'm using the formula that the expected value of the sample mean is equal to the population mean, and the formula that the variance of the sample mean is equal to the population mean, population variance divided by n, right? Okay, good. So these are two examples. Now the next thing I would like to do, let me check the time. Okay, we have time. The next thing I like to do, is the following. You may remember that I gave you two different. Let me do some more examples. All right, this is example 3. Example 3. Right. So suppose. Right. So this is an example on the random. Remember, I defined a random sample to be independent random variables that have the same distribution. So here you have a random sample from a Bernoulli distribution with parameter p, and we want to find this. Now, do you guys remember the Bernoulli distribution? I mean, you just finished doing probability 1, right? How did, I mean, yeah. So the Bernoulli distribution is basically, it takes the probability p if x equal to 1, and it takes the probability 1 minus p if x equal to 0, right? Now, this is the probability mass function of a Bernoulli, right? Now, you can also write this as follows. You can also write this as this, right? Because if x equal to 1, you get this simplifies to p. If x equal to 0, this simplifies to 1 minus p, right? So this is the probability mass function of a Bernoulli. So the joint probability, that is the probability that this is the joint probability, yeah, can be written as follows. Because of independence, by independence, right? Right now, each of these guys takes this formula here. So this is gonna be p x1 1 minus p 1 minus x1. Then this is p yeah, you follow me, right? Okay, come on guys, if you haven't done probability 1, then I don't know what I can do. But I thought you all of you have done probability 1 in semester 1, or did you not? I can send you some books on probability 1 if that is helpful. I mean, there are many books on probability 1 you can find online. I can send you some books. I can send you guys some books on probability 1. Or you can ask the professor who taught you, or you can ask the professor who taught you. All right, anyway, so this guy here reduces to this, right? And then you get, this one can be further simplified. Anyway, if you haven't done probability 1, can you send me an email and I will send you some books, okay? Just send me you know my email address. So just send me an email, right? And telling me that you need a book, then I will send you one, right? Okay, so this is the joint probability of the random sample if the sample comes from Bernoulli distribution, right? Is this clear to everybody, guys, or no? Yes. So you guys send me an email about then I will send you guys a book, all right? Okay, so this is example 3. Now, next example I like to do is the following. I hope I have time. I mean, let me check my time. We have time, yeah, we have enough time. So the next example is example 4. Suppose suppose you have a random sample from an exponential distribution with parameter lambda. right? Find the joint probability that find this joint probability. So I'm sure all of you know. Come on, guys, wait, bear with me. Don't quit yet. I mean, just stay online, guys, until the end of the class, which is 11. We have time until 10 to 11. By independence, you can write this as, by independence, you can write this, right? By independence. Now we know that, that the joint probability for, sorry, in this case, we are dealing with discrete, but I mean, I'm abusing my notation here, but anyway, the density for the exponential distribution, which is lambda times e power minus lambda x1, right? And lambda times e minus lambda xn, right? This, I'm sure you might have covered this distribution in probability 1, but if not, we will talk about it later, right? So this becomes, all the lambdas add up to lambda power n, and all the exponential terms add up to ef minus lambda, sum 1 to n of xi. All right, so this is example 4, right? So now, one more thing I like to talk about, if I have time today, is the following. Just maybe I will. All right. You may recall that when I talked about the sample variance, this is what I said. See, remember, there are two formulas for the sample variance. This is known as the biased version, and this is known as the unbiased version. And usually the unbiased version is the better one. This is the better estimate than this one, right? The reason for that is because, this, because you should take the expected value of this, right? Right, this will be equal to sigma squared, where sigma squared is the population mean of the sample. Population variance of the sample. Whereas that's why this, that's why it's known as the unbiased version, because the expected value of the sample variance with the n-1 in the bottom is equal to the population variance sigma squared. Whereas the other one, you should take the expected value of the biased version, which has a n in the bottom, right? Usually this will not be equal to sigma squared, and again, this is that. All right, it's exactly because of this that this is known as the biased version of the sample variance. Yeah, bias here means flawed. Yeah, you're right, sir. Yeah, so here this is known as the unbiased version, which is good. A biased means not good, right? Okay. Now you can actually well, sometimes not all the estimates are. Sometimes it's not possible to get unbiased estimates, and so it is. Sometimes the estimates that we get are biased. But in this case, it is possible to get unbiased estimates, right? Now, let me call this star for a reason. Well, I mean, we will talk about estimation in the not right now, but it will take like few weeks. I think week 4 or week 5 we will talk about estimation. So I prefer not to answer your question right now. But anyway, but the thing what I'm saying right now is that it is possible to. It's not really hard. It's not really hard to prove a star, that the star, what I mean is star is this equal here, that the expected value of this is equal to sigma squared. And I don't know if I have the time to prove it today, but let me check if was the time. Yes, sorry, I don't have the time to prove it today. So, but when you have time, I mean, I don't know how much time you have, but when you have time, right, just think about if you can prove this equation that the expected value of this, I mean, it's equal to the population variance sigma squared. And next time I meet you guys, that is next review session, I will prove it. And before that, we have tutorial sessions. Okay, you want to see example 3 again? Sorry, just a minute. Before that, please don't forget to attend the tutorial sessions this week. This is example 3, sir, Jack. By the way, I will post the video as well as the handwritten notes from this session on the course website. So you will be able to see everything I talked about, everything I wrote in a few minutes time, right? So you want to see example 4, sir? Did you say example 4? This is example 4. Anyway, I mean, I think both the notes and the videos. You need both, Bailey. So to answer your question, Bailey, you need to watch the videos as well as read the note, as well as read the notes. It will be good if you can do both. All right, guys. So I will see you guys. I will see you guys in one of the sorry. I will see you guys in one of the tutorial sessions this week. All right. So take care of yourself. I will see you shortly this week. Right.
Have a nice day.
Thank you. Bye.
Thank you very much.
Thank you. Thank you, sir.